Hi guys, so we're going to talk about worksheet 2.1, and this is all about the atom for this unit. We're talking about, in this one, the number of protons and neutrons in the nucleus and the number of electrons. And we have two types of notation, and then we have several numbers that you have to calculate for me. Most of this math is very simple. If you want to use a calculator, you can, but most of it you should be able to do in your head. So, in the case of sodium, we have the symbol here, notation would be the symbol Na, and then at the top we have 23, which is the mass number, and then at the bottom we have 11, which is the atomic number. And so when we write it as a name, we write it as sodium-23. Atomic number is the bottom number, mass number is the top number. Charge would be the difference between the protons and electrons. If these numbers are the same, it's 0, as it is in this case. Number of particles in the nucleus is the same as the mass number, and the number of protons is equal to the atomic number, which is 11, and then the electrons is also equal to the atomic number. And then to get the number of neutrons, we subtract the number of particles in the nucleus minus the protons, which gives us 12 in this case. So let's work an example. The symbol here is Cu, which is the symbol for copper. And then we're going to put a dash. We're going to put the mass number, which in this case is 60. And then here under mass number, we'll put 60 again. The atomic number goes here, which is 29. We don't know, we know that this has got no charge since it has nothing listed here. Here we see it's a +1. So we know that the number of protons has to be 29. The number of electrons has to be 29. And the charge has to be 0. Number of particles in the nucleus is going to be the same as mass, which is 60. And then we're going to take 60 minus 29 to get the number of neutrons, which in this case will be 31. 31 plus 29 equals 60. Let me work this one that has a charge so you see how that works. So this is going to be potassium. And again, the mass number is 41. Kind of ran out of room, put it there, 41. That means the mass number goes here. This bottom number, 19, is the atomic number, which is also the number of protons. And 41 is also the number of particles in the nucleus. I know this charge has to be +1. And please put the plus as well as the 1. And if you put it in the back or in the front, doesn't matter. To get the number of neutrons, 41 minus 19 gives me 22. Now I have to have more protons than electrons because protons are positive, electrons are negative. I cannot lose protons because it'll change the identity of the element. And so I have to have lost an electron, which makes this number 18. So when you're getting a charge, whether it's positive or negative, you only change the electrons, never the protons, and protons must equal the mass number, which tells me the identity of the element. I hope this helps. We'll talk about some of these things down here in class. I think you can get through this entire worksheet just on this video alone. Ask me in class if you have any issues. Thanks.